I would just like to dive to hydration. Well, I'll say something to the secretary next, because usually you get Shirley.
What is it?
Got it.
Conference over Jabber.IETF?
Yes. Okay, I'm set, I think. Morning. Hi, Rich. We'll chat later.
Yeah. Oh, thank you very much.
There's two.
And did we get note takers?
Yes, he's set.
Oh, okay, excellent.
Oh, so sweet. I can pull this shit over here. Yes. This will work nicely.
Well, and we see it down there, which is really nice. I do like that feature.
Yep. Okay, so back to that. Boom. Slideshow, paper start. Ready to rock. Who wants to call the ball here? Thank you for the water.
There you got the glasses.
Oh, so I'm the one I would.
We're all wearing
I'm
glasses.
an authority. Okay.
Oh, the shit. Hold on.
Okay. We're going to get ready and get started. If Mr. Thompson and Mr. Rescorla can sit down, please. Thank you.
I could do these two. All right, here we go.
We're official.
We're putting the band back together. Okay, go ahead.
Okay. All right. So the dispatch working group session. Next slide. We've already got people have already volunteered for note takers, Jean and John. That's awesome. And now the note well. Is this the new note well? Did you pull down the new one? Okay.
It's new from when?
Oh, they sent a link like this week. That's okay.
I'm the
Okay.
one behind.
This is the old one. Okay. Everybody should have already gone and read the new one. Okay. And then Murray's going to give you the quick and easy.
Right. You have the right to remain silent in this room. Anything you say can be used by the IETF. If you have intellectual property rights or obligations, you should consult with your attorneys before participating here or on any list or talking to ADs in the hall or any of those ways. Okay.
All righty. Okay.
We have not discussed these, but.
No, we haven't. Okay. So this is the deadlines for IETF 100. So you've got a little over 2 months for BOF submissions. To add over that, to let the chairs know that you've got something coming in. And then the cutoff for charter proposals, really, this is your problem statement. What problem do you want to talk about solving, and what deliverables you might have if we decided to solve that problem? Doesn't have to be an official charter. And then we will announce the topics. We were remiss in doing it for this meeting, and that's for 100, of course. Typo. Yeah. But we will shortly update the wiki. Okay, there. Okay, so working with the deadlines. If you make the deadlines, and obviously you're going to get agenda time as long as the topic has had sufficient discussion and sufficient interest. If you miss the deadlines, you get into the AOB section. If we have time, we'll talk about it. And it is super helpful for the chairs if you include your draft - your name - dispatch. It makes it a whole lot easier for us to just make sure we don't miss somebody, because we do occasionally miss somebody. Okay, mailing list. So art at IETF.org is for general discussions, general RI topics. And then the actual work that you want to do on the dispatch mailing list. We're not super strict about it, but it's kind of we found this worked well in the past, right?
ADs. Does anybody want to get up? Any of the ADs want a few minutes of my time? Oh, send the blue sheets around.
Oh, we missed. I'm sorry. I forgot.
No, that's right. It was right up front.
This is Ben. I don't think we have much. I will highlight that Solar is meeting, which Adam described as them meeting is kind of like a solar eclipse. So if you want to see it. Other than that, I do not believe we have any updates.
One thing to note is that Apps AWG has finally officially closed. Thank you, Alexi. I see him sitting there, but he's not jumping up to the mic, and I haven't seen Adam yet this morning, so I think that's it for this slide.
Oh, he's back there. Okay.
Thank you.
Oh, okay.
Mark, I will shoot you with my laser beam glasses from here, from the projector.
Web packaging, Jeffrey. I'll get the slides going here.
Oh, we have web packaging first. Sorry.
Months, all right. What's the problem?
I thought we had them the other way.
I was listed first.
Okay,
It's
perfect.
not
I was just
consistent with
confused.
what I saw.
Excellent.
Where is the tool? It's full screen. Which one's it under? I can't see with these
Oh, you
glasses
can't
on.
see.
Do it full
Well,
screen.
here, you can see the screen there. Can you read the screen in front of you?
Oh, that's awesome.
Yeah.
Yes,
just
that
do
is
it that way.
perfect. Yeah.
I think it was right up here. See that guy?
Okay.
Right.
I'm Jeffrey
This is a different
Yaskin.
slide
I work
from
on Chrome, and
Oh,
I'm
okay.
bringing a proposal to package websites.
Next slide.
Yes.
There you
So put this on here so you know approximately how much longer you have to listen to the presentation. Next slide. So the proposal came out of some research about emerging markets that showed that users have this existing ecosystem of applications that they use to share files around. And we wanted to let them share websites and web applications in addition to the videos that they're currently sharing. So the top two kind of use cases drove the initial design of the format. And then a bunch of people came out of the woodwork and said, we think this would be useful to us. So the top two are that some author should be able to produce a bundle of their website, including kind of service workers and CSS, JavaScript, HTML, images, sign it, and then let people download it and share it peer-to-peer over cheaper connections, like Bluetooth or Wi-Fi Direct. And then those people should be able to install the application, connect back to the original server, and treat it as same origin. So get the right URL bar, get the right JavaScript permissions, and so on. Second use case is users should be able to create these bundles, which means we also need an unsigned, a way to do them unsigned. And then there's some use cases around certain limited CDN ability. So it's intermediate between normal CDNs where they can write anything as the website, and just copying the data. Then we thought like enterprises might want to give extra permissions to web applications they've vouched for, and the format also seems to allow that. Some people think that HTTP2 push is hard to configure, so they think that web packages might be an easier way to do that. And then some node people and web publication people are also looking at using the format. Next slide. So in order to get the peer-to-peer website sharing, things have to be signed. We have to make sure that we don't get around existing certificate revocation procedures. We have to make sure that if an XSS or other vulnerability is found in the site, we have some way to prevent that package from being used by attackers. We want to be able to access things within the package randomly rather than by seeking through it, so that people using SD cards can use the packages. And we need to be able to update the algorithms used for signing the packages over time. So we need some way to tell the server that the client supports certain algorithms, and then ways to incrementally upgrade packages to support both old and new clients. To replace MHTML, we need also a way to do bundles that aren't signed. Next slide. To help with the CDN use case, the package needs to be incremental. This is one of the two considerations that makes us think that zip isn't the right format. So we want to be able to kind of top-down understand a package. The intermediates should be able to take out resources that they know that a particular client doesn't need. And then we've gotten suggestions that maybe instead of, so kind of as an alternative to a package format, maybe we want to do a way to sign the individual resources instead of having to bundle them in order to get a signature. And then for enterprises to use it, we want kind of non-web certificates to be able to be used to sign packages, in addition to the web signatures that are kind of the primary authentication. Next slide. So the draft that we published is based on CBOR, but the kind of underlying encoding is still to be decided. We've gotten suggestions for ASN1 and multi-part. Right now, CBOR looks like the best, but one reason that we're asking y'all to look at it is to figure that out. So we get the packages consists of a signed list of resource hashes and a list of kind of sub packages, which are themselves those signed lists, so that you can have a package built from multiple origins. The content is a map from requests to responses, which is the second reason that zip doesn't look appropriate. Instead of file names and files, we have like HTTP sessions. And then we haven't yet designed the certificate validation and downgrade protection, but we expect to treat that as kind of a parallel package that can be downloaded more frequently and passed around, kind of attached to the main content. Next. So we have a bunch of questions for all of you. Are we even in the right place? We started this work at the W3C, and I thought that some pieces of it were more appropriate here, but some people have said we should just keep doing it in the W3C. Let's see. Is a packaging format even the right thing to do? Maybe we should just do new HTTP headers and then some parallel bundling format that would definitely not be here. And then we need to nail down all of the format and get kind of any other feedback that people can see. But I guess the main question for this group is like, what venue is appropriate? Is it here? Is it a new working group? Is it an existing working group? And so on. And I believe that's everything. Mark.
Hi. Hold on. Yeah. You can hear me. Oh, it's really annoying. Hold up. There we go. Hi, Mark Nottingham. So I was kind of one of the folks who looked at this and said, no, you should probably just do it all in the W3C at first. But after some thinking and some sleeping, well, first of all, I should say that there's a bit of history here that folks might not be aware of, in that the W3C has thought about this before in various forms. And the W3C tag had a document that has been going on for quite some time and then kind of died. So it's not that this is the first time this sort of thing has been proposed. But I look at this now, and after the thinking and the sleeping, I can see a place for some of this work at the IETF. And in the conversations we were having, I would really recommend splitting it up into some components, because a lot of the capabilities you're talking about here can be useful in other ways. And so I see it as kind of, you need a format to persist a set of HTTP requests and responses, because I think this is HTTP specific. And you need a way to assert that a HTTP request response pair is from an authority. So that's something like a signature that applies to, either a package or to an individual request. And then you need, the glue that ties that into the use cases that you're interested in. And those first two do seem like they're in scope just because they're very specific to the protocol. And I'm starting to think you'd have a better chance of succeeding doing that protocol stuff here rather than over at the W3C. The gluey stuff about the browsers probably needs to go over there.
Definitely.
And I was kind of looking around for my co-chair in HTTP, but for some, oh, there he is. Hi, Patrick. For some, personally, I think that those first two items could fit in the HTTP working group, or at least it's worth a discussion.
So, Mark, I just have a clarifying question for you.
Sure.
So, on the gluey stuff, the signatures.
No, that's number 3. Signatures are number 2.
Signatures are number 2.
Yeah.
Okay, which would be, you're suggesting would also, I mean, obviously IETF's done a lot with the signatures.
Well, signatures is the mechanism, but what the really itchy part of it is going to be, and we're talking about this in HTTP right now, is how do we assert that, I get some random bits on the wire somewhere, how do I know that they're from an authority?
Okay, I guess my clarifying question I was trying to ask is, what are the parts that you think should be done outside ITF? I just got a little bit lost in what you were saying.
Okay.
That was all.
I think that we can specify a format to persist HTTP request response pairs in a convenient to consume way. I think that we can do a way to assert that a request response pair came from an authority. But in terms of, and so those are, kind of basic functions. Specifying how browsers will actually go and support those in certain use cases is maybe out of scope for us. We just want to define the basic mechanisms.
And can you kind of, what am I going to say? Is this all the kind of thing that could be in scope for HTTP BIS or for HTTP? Or are you thinking another working group?
So my kind and wise co-chair, which I'm really enjoying having a co-chair, by the way. Thank you, ADs. Just pointed out to me, it reminded me that to persist a request response pair or multiple associated request response pairs, obviously. That gets you your packagey stuff, although there's some pitfalls there. And if I put my ex-CDN person hat on, I think that there are a lot of pitfalls around those use cases. I think that this is HTTP specific, probably.
So you would recharter to contain it if you haven't already, if you're not already there?
Sure, we could recharter.
I just shooting from the hip. Thanks.
Our work mode right now is we just talk about a document, decide to adopt it, and adopt it. We don't recharter much. I don't know if that's a surprise to our idea or not. But I will, sorry. I will point out that I strongly believe that trying to make it protocol neutral would be a horrendous mistake. We've been down that road many times. It doesn't work. Don't do that.
Philhan Baker Komodo. I've looked for it a few times, but is there actually a proper specification for MHTML?
I believe not.
Yeah, because that's something that I think you need to fix. And I don't think that it's a good idea to do this in HTTP. I think that that's a working group that has, well, you're already doing 2 sessions, etc. I really think that packaging is something is separate. I'm currently working on something related. Imagine you're doing this, only all the data on the server is encrypted and stays encrypted because I'm doing end-to-end web. So you upload an encrypted website, you have encrypted forums, and they're only ever decrypted at the client end.
Great.
So I'm working on that, and we can talk offline.
Yeah, the kind of first 2 use cases don't work with end-to-end encryption. The confidentiality kind of breaks them. They need to be authentic.
Not until PHP. I've got it running end-to-end. And I'm not using the crypto that you know.
Okay.
Magnus Westlund Ericsson. Yeah. So have you looked at the out-of-band encoding for HTTP? There's a proposal.
I was pointed to it yesterday.
Okay.
And I
Answer the question.
I have read, I think, the introduction.
Yeah. Yeah. No, I mean that's trying to solve this kind of side delivery from another node with the same origin same origin policy within, etc. So that's at least a piece that's currently ongoing.
Yes.
It's a proposal at least.
Martin Thompson. I'm less sanguine about this than Mark is, I think. When I first saw this, I thought, oh, well, this isn't yet another iteration of the same thing that I've had pitched to me umpteen times. But when I actually looked at your requirements, this is not about packaging at all. And it's more about the sorts of things that Mark was talking about in terms of passivating HTTP request response pairs and having some way to deal with them offline. And the out-of-band encoding and various things sort of pushes in that direction generally. I'd caution, however, we don't know that server push works in H2. And one of the challenges with server push in H2 is having someone guess what someone else might ask for and when. And there's a real challenge in solving that particular problem. Yes, oh, come on. Mark's saying, oh, that's not a problem. What are you talking about?
Yeah, we've had that internal debate.
There's been a lot of debate about push and how to actually get it to work. And it's possible that within a narrow context you can do something. But you are creating that problem. How do you determine what requests that someone might want to make?
Yep.
And how do you ensure that they have the things that they need to actually build the application that they want without actually talking to a server? And the other thing is we've tilted at the signatures windmill so many times in the past that I don't know that we have this. Well, I personally lack the stomach for it anymore. It's really, really difficult. And it may be that if we can work out the passivation problem, then it may go away. But yeah.
Eric Pasquale. I mean, the passivation does seem at the heart of the problem here. It was already kind of a very odd hack and push to be like, you're about to ask me for X. Here's Y that I would give you if you gave me X. And that's like things that are milliseconds apart. Having it be weeks apart is extremely odd.
What do you mean by passivation?
This idea of here's like the request which you might be about to send me. I mean, your format contains basically requests and responses as if these were like being sent to the wire, but they're just sort of like pre-canned, right?
Yes.
And that is like an odd sort of structure for like something which effectively is a zip file. It sort of made sense in push where effectively what we're trying to do is hoist this in the HTTP layer. But what you have is really and have a very light touch. But what you have is the contrary. You have like this extensively pre-processed kind of set of data, which you have to make sure you have the transitive closure of all the resources. And so like treating that as sort of a stored HTTP session strikes me as like kind of the wrong architectural level. I'm not quite sure why that's, why that seems like an attractive notion. I actually got to talk about the security for a second. Those HTTPS credentials are there for a reason, and it's not for you to sign things over the long term. It's not exactly clear the security properties that ought to be. To be concrete about this, if you allow the HTTPS key to be used for signatures which span weeks, that creates a very substantial additional risk if that server is ever compromised.
Yep.
Alexi, would you get in the queue, please?
This is Daniel Kahn-Gilmore from the ACLU. The idea that this is framed as packaging and that you're talking about basically shipping web-based applications raises all kinds of questions in my head about the package ecosystem management, package dependencies and things like that. Mm-hmm. So there's a long history of work with this, with Linux distributions, with language-specific packagers. Every one of them gets it wrong, and it is really complicated to get the dependency management and to avoid things. I mean, you mentioned downgrade attacks. It says something like not yet finished or something in your slide earlier.
Yeah, we have an idea, but it's not designed fully.
Yeah, it's also not designed fully in NPM. It's also not designed fully in pip. It's also not designed fully in Debian. I mean, this is a complicated and difficult problem in an ecosystem that is centrally managed. And we're talking about doing this in an ecosystem that's distributed. If you're aiming to do it for actual packaging, like full-on packaging work, and you want to get the security properties right, this is a tremendously large endeavor. So I just caution you about that.
Thanks.
I don't, other than to say that like, we should, if you're going to do this, you should look for the folks who have prior art in it, and make sure that you're not making the same mistakes that they've made. We've seen language-specific package distribution mechanisms make the same mistakes that like Linux distro package distribution mechanisms made 10 years ago. So I don't want to make another 10 years where we are making the same mistakes down the path.
Pat McManus. So I think I've sort of heard three major components here, and one is about a persistent independent format for HTTP requests and responses. That would certainly be something that could potentially be in scope for HTTP BIS if they chose to take it on. There's also the blind caching or out-of-band encoding stuff, which I think has strong applicability. I think a similar comment for that for venue. But then we're also hearing what DKG is just talking about now, which is essentially the accumulation of N of these things together, and then how that's interpreted in clients and how you access them within the package, whole or in part, and all that kind of thing. My inclination is IETF is not the right venue for that part of the work.
Alexi, we've been sort of discussing off the mic here how we feel this might be dispatched, and Mark has said that some of this might go in HTTP. Cullen feels that some of this stuff might be better suited for a small dedicated working group. Chances are this is going to land in your lap no matter which way that goes. So what are your thoughts on this?
You're really putting me on the spot, are you?
Sorry. Correct.
Yeah, I just whispered to Mark saying, if some of this goes to HTTP base, I will have some input on it, meaning that, I think we need to have a more fleshed out proposal in the sense of which piece is going to be done and what's deliverable. And I don't want the HTTP base working group just to say, well, we're just taking that without deciding the bigger picture of where this is going to land. I don't want to give the answer to your question. I think it might be one existing working group and maybe some others to be created if people are interested. But I think the most important question is actually, are people interested in doing this work? So I would like to have some indication that, it looks like, people came to the mic and they were marginally concerned and interested, but I would like to know how interested people are in.
So would you like us to stage a hum, or do you feel like you have? Okay, go ahead.
Yes.
Well, I was going to say before we do, but we've got a lineup behind that makes sense. Good input. That this looks like one or more working groups split across, right? That seems to be where we're going, and we need to get more details on that. But let's do there's a lineup of the mic. Let's hear what people want to say, and let's also hear anybody who wants to speak about the relevance of this and whether we should, are there people interested in doing this work? And then we'll ask specific hum questions like Alexi asked for.
All right. Mark Nottingham again. So to be clear, I don't think that this is something we should be talking about chartering something now or bringing into HTTP now or whatever. I think describing the use cases more carefully, probably paring them down to the core, and then describing, breaking out the underlying mechanisms that could be used to achieve those use cases, to solve those problems, would be the next step. And definitely having some conversations here and elsewhere about that would be good. But it's not something that we want to talk about in HTTP this week, for example. But please, I would love to be involved in those conversations and help out with that. Putting my liaison hat on, I think this is something we want to talk to the W3C about before we took any steps as well.
Yeah, Martin Thompson, I was a little concerned with the presumption that we were trying to find a home for something, but I think Mark managed to capture most of the comments that I got up here to say. I'd like to see a little more clarity about the requirements and the solutions that fit those requirements, because what we currently have is a big ball of wax with another big ball of wax to address it. And there's some good parts and there's some bits that might be completely unnecessary. And I think the framing as packaging is immediately problematic. And the core things that you actually want, if we can solve those problems, and I'm not sure that we can completely solve all of those problems, but we may be able to make some serious progress on them. If we can solve them, it would be good to actually identify those individual things with some more clarity.
This is DKG again. Sorry, I just wanted to clarify my earlier comments about packaging, which is that while I don't see that there is a place within the IETF to do that work, I think if you go ahead and you define signature formats without actually understanding the scope of what's needed to be signed and what's not needed to be signed, then you could build yourself a really dangerous thing that isn't useful for the actual package management questions that you want to answer.
Right, and the YCG repository and README have a sketch of how to define the tree of subpackages, and what I'm hearing is that I should flesh that out a lot more.
In terms of a venue for discussing this, you could start it on the art list, and then if this gets big enough, you could request a dedicated one.
Ben Schwartz, Jigsaw. The chair's mentioned speaking to relevance. I just wanted to say, I think this work is very relevant and useful to my needs and applications because it has real potential to serve populations who are cut off from the standard internet or from parts of the standard internet.
Paul Hoffman, this is actually for the chairs on whatever hum you're going to ask. I also have the concerns about signed packages because people easily misinterpret them. In the DNS world, we have this thing of, you watch a query response, and then you sort of know what's there. And it sounds like one of the things you're doing is sort of almost mimicking. So ignore the fact that you're packaging it, but you're sort of saying, if you had given this query at this time, this is the whole thing your browser would have gotten back. But now it's a different time, that we know that we froze that. We all know that if you sort of close the browser and then open it up 3 hours later, you can't necessarily use those resources exactly the same way. Some of the things they point to may be dead and such like that. I am really concerned about signatures over some things that even if the signature says at this time you would have seen this and you believe that, I think it's widely open to misinterpretation. Maybe this is where DKG was going. So I would say one of the hums might be, if you saw one of these things, would you be able to use it? I believe I would be able to use it. I think maybe this goes to what Ben was just saying. There are people who could use this if it was unsigned. That is, this is just a chunk of things you might have gotten. Please don't believe them more than that. But the signing, I think, is going to be really easy to misinterpret, especially about future use of that.
So I guess at this point, I'm thirding Mark and MT. I think it'd be useful to just take the entire bottom of that document and chop it off and start with a use case and requirements document, and then we can take the mechanisms and put them in some file aside, and then once we have the use case and requirements, we can discuss which of those things we want to pull back in. But it's really hard to sort of be like, here's some giant problem, here's some giant solution. I think if we had a use case document, we could talk about whether or not we could, that would be something we should charter to do work in. But I wouldn't want to charter to do work and say, here's a giant use case document, and here's a solution which we're starting from. That doesn't seem like a very good place to be.
Okay. So I think we're getting pretty consistent feedback here on hey, there's some work to be done, various places or whatever, and reel that in. So and this wasn't trying to form a working group today, right? We're not at that stage. We're trying to divvy up the work and get the requirements like multiple people said and what just Ecker said. So the question I think that we have here is, if we'll move forward with discussing this on the art list, how many people are going to participate in this conversation and help move this work forward? Put your hand up if you're willing to, help do some work on this. 10. Okay. And I don't know. Alexa, you got any other questions you'd like input on? Okay. Anyone have objections for us running this discussion on the art mailing list for a while? And if the traffic gets too high, which I don't foresee happening, we'll spin up a separate mailing list for it. But keep doing with the focus initially on let's try and nail down better context of what's the shape of the problem we're trying to solve. What are all the pieces? How do we split them up a little bit finer? And then we'll figure out where the work goes. Is that fair enough for people?
Just a quick feedback from Jabber too. There seems to be a lot of interest in having a BOF do that stuff.
A BOF. Okay. Why is Mark making a funny face?
What about the BOF?
That's his usual face.
Well, it's funny.
Options are certainly a BOF, dispatching and in dispatch. I think as we look at the scope of the thing, it'll become real obvious what the next steps are. I'm not worried about that. We'll cross that bridge when we
show the deadline.
When we find the trolls under it.
There they are. Okay.
Okay. Thank you.
Thank you. Yeah. Here's your link slide.
Mr. Hoffman?
Mhm.
No, we're good on
That's
time.
fine.
We're doing this. We're 6 minutes ahead.
So begin. Close enough. So I'm Paul Hoffman. Some of you remember me from when I used to come to art, kind of things long ago, haven't done in a while. I'm going to give the presentation. Patrick McManus is going to help me with some of the answers because this is very HTTP-ish, and he's more of an HTTP-ish kind of guy than I am. I'm a DNS kind of guy. So this draft has been out for a little bit. We have an 01. Next slide, please. This is sort of a tar baby. It's very obvious that you can tunnel foo in HTTP, and this group is good at hearing those proposals and whacking them down. We think that we have actually dealt with some of the obvious questions at first, but the main reasons that we want to be doing this specific kind of tunneling and for this specific data is there's a couple of them. It's not a single, this is going to be everything. One of them is that, in fact, HTTP2 is a more reliable transport for this DNS queries. And we know that browsers and other, HTTP itself relies on domain names, so that it getting the DNS data itself in a transport that it's already doing is a logical thing. A separate orthogonal but also useful use case for this is web apps, JavaScript and such like that. At this point, can only ask, what's the address of foo? And the DNS has a lot more information than that. And with this, it might be able to get fuller information. That kind of information could be valuable. It hasn't been available, so people haven't really been pushing on it. But remember, the DNS is not just a place where you find an A or a quad A record. You might want to know its origin. You might want to know how you got there. You might want an SRV record, things like that. So both of these use cases are achieved by doing DNS in HTTP. And to be clear, in this document, we are not saying for the HTTP client what you can do with this DNS information. That's completely up to the client itself. We're not saying you're going to trust it this way, you're not going to trust it this way, and such like that. It's a way of getting the DNS information. Next slide. So also to be clear, because some of the people who come here to dispatch with the foo over HTTP say, well, we only want these parts of HTTP, and so we're either going to break some HTTP semantics or just ignore them. We have made a really, really strong effort to not ignore anything from HTTP and to do it right. So content negotiation, proxy and caching, blah, blah, all of that, either we've already done or we intend to do, or if we did it wrong, we intend to fix it. We aren't trying to do HTTP except X, Y, and Z. We want this to be real HTTP because, again, from that first slide, we want this to be used by HTTP clients already, and we don't want an HTTP client that is all, are you shaking your head no, are you playing? Thank you. Okay, good. I was like, ooh, boy, because this is really basic to our idea is if you're an HTTP client and you want this DNS information, you shouldn't have to forget part of your brain when you get it. It should be just like stuff that you're getting. So we really do want to, just do all the best practices stuff, et cetera. So next slide. We have a bunch of things where people said, oh, you could also do this. We're not doing that. So we're not, DNS64, it was a bad idea. We're not going to try to touch it. And the last two bullets are the most important ones. We are not trying to support insecure HTTP. This is H2 over TLS, just like the way H2 is supposed to be. And therefore it's H2, which is not H1, H1.1, H0.1, whatever. We are not trying to say, oh, well, if you don't really know all of HTTP or a current HTTP, you can still use this. No, this is for mainline HTTP. Next. So let me do a few slides for those of you who haven't looked at the current draft of how it looks today. I'm emphasizing today because, in fact, it's just an 01 draft. If dispatches is somewhere and such like that, then this is all open, just in the same way that lots of HTTP groups. One of the most important things is that you marshal the DNS wire format for your query and for your response, which takes a little bit more work, but what you get out of that is full support for DNS. So instead of this being sort of like, well, right now you can get addresses and we want to give you some more and we'll tell you which more. The mandatory to implement content format is the full DNS request, the full DNS response. Now, there might be additions later for different formats that are less than that and easier, and I have a slide on that. But the idea here is that the DNS folks, I'm one of those, there's a few other in the room, have already said, this is the way the DNS world looks, this is the kind of data you can get. That kind of data should be available to a DNS client, I'm sorry, to an HTTP client. So we use the wire format, and in the current draft, we also do get and post. Some people have said we need to pick one. I've got examples of both of them. Each of them has their own use case, their own value case. They both are, like 90% the same, but the last 10% is different for the two of them. But right now, the draft says, here's how to do a get, here's how to do a post. Next slide. And here's what the get looks like, which is a normal get. The one funky thing in here that you might notice is in the path, we actually put the content type as part of the path so that you can see that. And again, we are content type agnostic. So this is the content type that's described in the draft, which is, as you can tell from the name, since content types are supposed to have descriptive names, this is the DNS UDP wire format. So that's what it is. And then the body is that, done out as base64 and such like that. Notice on the last line, though, that in fact it can accept answers both in the wire format or in this other one that I made up, which is simple DNS or others. So again, like normal HTTP, the query format doesn't have to match the answer format if you're able to do that. Next slide. And so post looks similar, except for the fact that, of course, you have content type as a real header and such like that, but looks like a normal post. Next slide. And then the response you get back, this is an example of the response coming back in the wire format. It looks like what you would expect an HTTP response to look like. And again, that glob of hex at the bottom is a real DNS response. If you have a DNS parser for the message, that will come out looking exactly like what you would expect. Next. So as I said earlier, we are saying mandatory to implement is the wire format because that gives you all of DNS. There's nothing more to give you if you can do the wire format. There might be other content types that people want, and for example, for web apps, for JSON, a JSON app might just want an address, but it wants to get the A's and the quad A records, at the same time. So I did a really simple draft, which is called simple DNS JSON, which, the query looks like JSON, the response looks like JSON, blah, blah, blah. Other people could do others. This one might be expanded more to say cover it, SRV and such, but I'm not saying that this is a right answer or a good answer. We're just emphasizing the fact that this is really an HTTP usage, so content types can be added. Next.
Right.
And then, so really the question is, so why are we coming here? We want enough other review because this is DNS folks, HTTP folks, and sort of AppSy folks. So we would like a working group that might do that. We think this is pretty easy to charter. And I sent you guys one. You might, so I didn't put it up here, but it's just a few sentences that Cullen said he would love something that was 3 sentences long. I think I made 4, but yeah, okay. You're
over your quota.
Yes, exactly right. But that was meant to be short, and so we think this could actually be done quickly because we're not trying to boil the ocean. So that would be it. Now, Patrick, you're supposed to come up here and help me defend myself.
Magnus Westland Eriksson. I have a question about how you determine or how you control which resolver, because I understand this is basically client resolver leg you're trying to cover. So
you're asking basically the same bootstrapping question you have for DH or for DNS, which is, how do you find your name server? Is that the question?
No, I was rather saying about the control. So, I mean, yes, for DNS today you configure it in some way, but now we move this into the browser, for example. And the browser needs to say, okay, is it the site that tells you which?
So you move this to an HTTP client, which could be a browser. So one of the potential use cases here, right, is simply, in place of a stub resolver in an HTTP client, and then you find a name server in the same way as you currently do, bootstrap through some kind of, operating system mechanism. Maybe PVD will give you a name along with an address, so you can use that for the HTTPS, establishment of that connection. That also applies, in the browser context, right? In order to find the recursive resolver it wants to talk to, or how the application wants to find the recursive resolver that's going to give it these things, might be application-specific configured, run by the JavaScript application that's distributed. Our intention is that's actually out of scope for this working group, discovery problems. This says, you have the name of a name server, just the same thing DNS starts with, except it starts with a, an IP address of a name server, right? In this case, you need a name because you need to be able to verify it across HTTPS, and an address because you have a bootstrap problem, obviously. So you need both.
Yeah, I mean, the reason I'm asking is because I see it's a huge dependency on the whole privacy aspects of this mechanism, and what it actually leaks to, and who you're talking to is actually depending on who's having control of which HTTP server that responds to your question and where it gets cached.
Yeah, so you're talking about like the use of this information. So I mean, clients already have this problem right now. They have a number of options of DNS sources available, right? I mean, I can use the one identified by my LAN. I can use the one identified by my ISP. I've got the one identified at, Quad 8, right? I got all those options. And this work is not intended to sort out which one of those you use for any purpose.
Or to say it's any different.
Or to allow you to use new ones. So, so the HTTP working group right now is taking on some questions about how you do or do not use DNS information in particular scenarios. That is not this work. So things like alternate services, which we've there's already an RFC on, right? Defines a HTTP client-specific relationship to routing, essentially, right? To use any data through this mechanism that, say, came directly from the origin that you happen to be talking to would require further work in a place like HTTP for how you use this information. What this work is about is defining how you carry traditional DNS information over HTTP, and like what the meaning of those fields are when you do that, so you can map that back into the old meaning. And that's the extent of it. And it intends to be a foo over HTTP draft done in a way that is well aligned with the needs and goals of HTTP, which is not always the case. So we actually kind of want to use it as a little bit of a trial balloon for establishing a good example of that.
Yeah. So I think it's interesting, but I'm worried about punting on the whole usage of this and how it impacts security and privacy concerns, etc. Because it has the potential to improve privacy in certain cases, but at the same time you need to kind of
but it's no different than what we have with getting DNS now, just in the DNS protocol. It's the same questions. How do you know, why do you believe, et cetera.
And certainly from a ComSec point of view, which is not the only point of view on a privacy question, it's a real improvement on the privacy thing, because it's obviously a strong confidentiality on the wire.
Mark Nottingham. I think this is good. I think it's just the right scope. I think you're right. It should be easy to charter, finish, and test. I think it's the right decision to punt on how it gets used for now. There are a couple of obvious cases and there are a couple of non-obvious cases, but that's a separable discussion, and this is achievable if you keep it tightly scoped. I'll probably have I've already given you some feedback, and I'll have some more, and I from my discussions, I think it sounds like you guys are going to take feedback seriously, which is great. So please, this sounds very good.
Feedback from most people, not yours.
Sorry?
So I would say actually feedback on HTTP as a substrate is actually an explicit goal of this work and should be in the charter. So
that would be cool. Yeah, and I have some suggestions which I'm happy to talk through. One thing you said, and there was some discussion on Jabber about why H2, why not, as you said, legacy HTTP. I think it's entirely reasonable to specify a minimum version if you have some particular, mandatory to implement, for example, in terms of performance and security goals. But you need to be careful around the language, and especially don't call HTTP 1 legacy HTTP, please. It's still in use. We haven't made it historic.
Right. So, I mean, there are some justifications for that. And the requirement is, as you say, a minimum version. It's not H2, it's H2 or greater. And we rely on the semantics defined at that layer, which is the goal. I mean, and the mechanisms, the draft goes into why those mechanisms I think are appropriate here. It's the priority, the multiplexing. And one of the things I like about 7540 is it sets an existing best practices security bar that H1 cannot be expected to do because of its older status.
Well, one of the interesting things you're going to have to work through in this, if this goes forward, is what happens when the peers mutually agree to downgrade to HTTP 1. Is that allowable in the protocol? Or do you sacrifice interoperability there? Because there's some cases where that might happen for whatever reason.
Easy to add.
Dave Lawrence. So I agree with Mark that this is very good and useful work that we should pursue further, and I like what you've done so far. I disagree with Mark to the extent that we should just punt on use cases. The issue being, as I see it, and as I've complained to Paul in the past, is that DNS over HTTP is a very ambiguous term. It means very different things to people in the DNS world versus people in the HTTP world, and that was evident in spades in the Seoul BOF, where we had 100 people in the room and half the room thought it was going to be one thing and the other half thought it was going to be another thing. And so to the extent that we can, to the extent that a DNS encapsulation format exists over the HTTP channel will be then tempting for browser and HTTP vendors to turn it into their goals of pushing more DNS data down the pipe. I'm especially concerned about how that part of the problem might turn out, and I think it really needs to be clarified as far as where that boundary might exist and what we're doing as far as encapsulation versus being a new source, a new channel for DNS information that might subvert the other aspects of the actual DNS system.
So clarifying question, are you saying that you want to see more in this draft talking about that or limiting it?
Well, at least acknowledging the issue. I think it has to be clarified that this is another competing idea over what the whole concept of DNS over HTTP is.
Sounds good. I just want to make sure you weren't saying, and we should say to people, it's not to be used for this.
No, well, I think even to the extent that we tried to say that
right,
exactly.
Stop anything. And people
So-
go, oh, that sounds really good.
The pragmatic part of me says, but I think the issues have to be identified about what that means. If you're going to start thinking about using it that way, here are some of the implications of what that is.
Okay.
Saturday. So if what you're doing is, as you've described to Magnus, you find your DNS server by some existing method that you would find any other DNS server, you make a connection to it and you treat it as you would a recursive or an authoritative server.
Recursive. Specifically here.
Okay, so let's say in this case it's a recursive server. You found it, you're treating it that way. It's a little bit unclear to me why then this isn't something we could just fold into dprive. All of the complications that I see in this are attempts, as I believe David Lawrence was just pointing out, when you attempt to blend this with other kinds of HTTP services, that it becomes something that isn't, this is a dprive mechanism that happens to use HTTP rather than DNS over TLS or DNS over DTLS. And I think it would be very valuable as you're going through the dispatch process to think about what pieces of this wouldn't work in dprive and why, because that might help you charter this in a way that keeps you out of some of the muddy waters that would be problematic.
To answer your question, dprive's charter is about privacy, and this wasn't simply about privacy. So that doesn't mean we can't deal with the question. I'm just, when you asked, why didn't we take it to dprive, it would mean a massive charter change for dprive.
So I agree it would take a recharter for dprive, but I think a different way to look at the dprive charter is to say it is about new substrates for the DNS protocol which provide privacy. And I believe one of the things you are creating is a new substrate for the DNS protocol which provides privacy. That may not be the raison d'etre for privacy may not be the raison d'etre for your work, but it is a required result of your work. Mm-hmm. And that is a good reason, I think, to think about why didn't this fit in dprive as you're writing the charter.
Okay, great, thanks.
Keith Moore. I think this seems like a huge can of worms to me. And one of the things I find myself very concerned about is the possibility that this ends up essentially forking DNS and ending with a more or less a special set of DNS servers that are intended for use by web applications. Because, you're providing what is more or less a web-specific interface to DNS. Now, it doesn't, I don't know that it has to be used that way. You could presumably write any application that used, DNS over HTTP2, but most likely it's going to be used by, web applications. And I feel like DNS is already polluted enough as it is. There are way too many interception proxies and special, servers that only serve parts of domains and things like that. So that the fundamental original goal of DNS, which is that it provides the same view of the internet everywhere, has long been compromised. But that's water under the bridge. We've gone so far down that road, but I really don't want to see yet another fork, another view on DNS that's only for certain kinds of applications, or at least it might end up being used that way in practice.
So while web applications are certainly near and dear to my heart, and they are a target use case here, it's my hope that you will have essentially operating system level libraries that are able to do this, right, in a way that we kind of envision for deprive. But when you do this, you get better mixing with existing HTTP and HTTPS traffic, which has strong properties for making traffic analysis a little bit harder and that kind of thing, right? So I certainly think there are, and certainly much better privacy properties than traditional DNS, right? So I certainly hope there's a role here for things other than web applications.
And this is not intended to do the split that you're worried about. In fact, it seems likely that if this protocol exists and there are servers out there, let's just call them servers that want to do this, a current DNS server could easily add the HTTP server part to do it. So it could be the same server with exactly the same data. There's nothing that says, oh, this is somebody who's only talking to web foos. It would be very easy to add if you think of it as another transport.
That would be fine with me. I'm just worried about the unintended consequence.
Sure. Well, there will be unintended consequences of not doing this as well, but I understand what you're saying.
Fair enough.
Hi, this is from John Clinton in Jabber. I'm trying to figure out what it would mean to use content negotiation to select variants, as one of the slides indicated. Given that DNS does not support a give me all the aliases for this name function, much less their properties. The draft talks about alternatives, but doesn't seem to say. Could you give some more info about that?
Right. Yeah, the content negotiation, John may be misunderstanding the content negotiation. I thought we were clear in the draft. I might have misstated it up here, but that's not for different names or different views of names. It's for the format that's coming back, whether it's coming back in wire format, JSON, ASN1, whatever. So yeah, you wouldn't use that negotiation to say I want these different kinds of names. So and if that's not clear in the draft, it really should be, because he's right. You don't get to ask that in the DNS.
Okay, Yavnir, I've got a couple of questions. In your first slide, you said that that H2 is more resilient or something like that as compared to regular DNS. And why is that?
Because with regular DNS, without any encryption, someone can see it and decide to block or stuff in. And if you've already got a TLS tunnel up, or whatever you want to call it, a TLS session up, they can't see it in order to know, oh, I want to mess with this or block this.
So you're comparing it to the old DNS, not the thing that Deprive is doing.
No, because Deprive, you can actually tell that it's a Deprive session. So if you want to block DNS traffic, you can say, I'm going to block traffic that looks like Deprive, whereas this might be something where it's already up, especially because we're using H2. Then you can, and this is a real use case, is let's say that you're using regular DNS to get an H2 session up. then you can switch into this if you're talking to somebody who is offering these kind of services. The outside would not know that now you're getting DNS information from them unless they were doing on path at some other place.
So we're trying to get past the evil firewall that's trying to block us at every.
It's not that that's not the only use case, but it would work for that. Yes.
Okay, so
and you can identify yourself as someone who makes evil firewalls, but
no, I don't. Not anymore.
Okay.
So anyway, the same firewalls tends to also negotiate clients and servers down from HTTP2 to HTTP1 by just throwing the ALPN extension out. So I think maybe you'd like to say HTTP rather than HTTP2 because those really get negotiated down with browsers that are willing to negotiate down to HTTP1. So if an implementation of this draft is not willing to negotiate down to HTTP1, it might get blocked.
Right. So I think I can make a case for H2, but I think that question is clearly in scope for the working group consensus.
Okay. So my other question, you had examples of get and post. When are you ever going to use post for DNS?
So in HTTP space, post has a better content negotiation dynamic because the content type and the 415 media type not requested response header pretty much apply to message bodies, not URLs, right? So it enables media negotiation in a little bit better way. The two methods are complementary. They both move the same, semantics of DNS data back and forth. One has better content negotiation properties. The other has essentially better caching properties. And as we put on the slides, I think in scope is deciding whether you want to be able to, allow the client to decide between that trade-off or whether you want to focus on just one. I think that's a totally reasonable question to look for consensus on.
Okay.
From John Clenson at Jabber, he says, thanks. The draft says alternatives, but the slide said variants, and that has special meaning within DNS. So there's the wording glitch to look at.
This is DKG. So I support this work. I think that actually having something like DO functional would be useful for the privacy properties that I think Paul just mentioned. I am concerned about the content type negotiation. That seems like an extra hairball that maybe we don't need to wrap in. You mentioned that they have the same semantics just in different structures. I actually don't think they have the same semantics, in particular because DNSSEC, you can't validate DNSSEC over the JSON format unless I'm misunderstanding it. DNSSEC signatures are signed over the DNS wire format or some particularly parsed variant of that.
If I said what you said, I said I was completely wrong because in fact the minimal format is much smaller on purpose. So I didn't mean that. I meant if somebody wanted to create a smaller or different format, they could, but the mandatory implement will be the wire format.
Right. So I'm just suggesting that it would be, I think, pruning off the non-mandatory to implement wire formats would be a useful simplification to make sure that we can get this out the door, because I think that people are going to want to be able to deal with DNSSEC and many of the consumers of this, and the extra wire format, the non-UDP wire format, the JSON wire format, as far as I understand, doesn't have a clear way to represent DNSSEC signatures unless your client already has a wire format parser or something close to it. So I would recommend pruning that off. I'm happy to not have discovery be part of this. I don't think that's something that we need. I'd just like to say, here's a way to do the transport that is compliant with HTTP semantics. I'm not so sure about the idea that there's just arbitrary endpoints. We have .well known for a reason, and I don't understand why this draft doesn't just pick an endpoint within .well known and say this is how you find that stuff.
It does.
So it does, but then it also says, oh, and then you could also do it in all these other places based on arbitrary endpoint provisioning. I'm saying maybe we could prune that as well if you wanted to simplify it. And I do appreciate the requirement for H2. So sorry, there's a bunch of comments there.
No, that's fine. But if we're discussing on a list, please bring those up because we actually disagreed on the penultimate one. So great.
And the mics are closed after the four speakers that are.
Yeah.
So first, I'm a little sad that we're talking about this, like essentially right as we're standardizing deprive, since it seems like whether or not one believes that that this duplicative of deprive is obviously a superset, and so like it seems like very annoying. I guess it's nobody's fault, but that's where we are. I want to push a little bit on this observation that Patrick made. I think that you can somehow have your HTTPS connection up and intermix your DNS requests. I don't actually see how that works. It's obviously the case that if you're talking to Google and your DNS server is Google, then maybe that's doable, but ordinary DNS server is not Google. And so you're not sending DNS requests to anything, HTTP and DNS are the same channel to anybody. So I just should understand how you get in this situation. So can you just walk me through it?
I can't. I can. So I mean, Google is one version of that. Any other widespread CDN may also have similar properties. Any version of
so I'm actually satisfied to have Akamai be my DNS server just because they happen to serve Facebook to me?
Not necessarily.
Not
You might be
necessarily.
happy anyways. So you might have a list of a large number of servers that you would be happy with. Right now, since you're carrying a laptop, if you go to a coffee shop, you sort of are inherently saying, and when I'm in a coffee shop, I'm happy to have whatever their recursor is. Most people
What an oddly unpersuasive argument, Paul.
I'm sorry?
What an oddly unpersuasive argument. The coffee shop controls my IP connection.
Yes?
That is not the situation with, say, the Akamai servers that are running Facebook.
No, but you may have chosen to allow that, is what I'm saying. So if you have a list of them and you're at one of them, then you can get DNS from them.
Yeah, I guess I'm really struggling to understand what actual setting this happens in, other than this particular 8.8.8 setting, which actually also isn't the same IP address, by the way.
We don't have it now. We believe that we absolutely could, especially with CDNs, with other large properties who you happen to like.
Okay, so this is a purely hypothetical
So
situation,
I
actually.
think there's also the HTTP VPN case. I mean, I think there are potentially a number of
No, but it's the HTTP
Has something
VPN
occasionally
case.
the
No,
origin.
that's
you're-
like, if it's the HTTP VPN, there's like also other tunneling mechanisms in play here. I mean, like,
Clearly, there are n varieties of tunnel. We're trying to specify something more than a tunnel here. We're trying to specify a useful definition of foo over HTTP that aligns with itself in a way that's more than a tunnel. I mean, that's part of the question.
sure, I understand that point, but I guess I'm finding myself persuaded this is actually a realistic use case of hiding this traffic. And the point where you're basically doing HTTP VPN, there's a whole pile of other things you have to do to make the system work. And those certainly would include tunneling DNS over HTTP. So where that strikes me, I mean, like the case I find much more persuasive, and perhaps people are in favor and perhaps are against it, is that as opposed to deprive, this conceals the ALPN token, thus lying about the fact that you're doing DNS.
It's not lying that you're doing DNS. It's not telling that you're doing DNS. No, that's different because you've started up to do normal HTTP, maybe or whatever, or maybe not. But you're saying I'm starting up doing, I'm using 443 for what I'm supposed to use 443.
This seems like an extremely fine semantic point from the perspective of the enforcement agent. I mean, bear in mind, the purpose of this from the enforcement agent's perspective is to control what you do. And so, and you specifically build this as a policy evasion mechanism. So, I'm trying to see you backing off that now.
I'm not backing off it. I'm saying that what we're saying is if you're on 443, you can be doing more things than pushing pictures of cats. You might be actually pushing DNS information.
I mean, yes, you might be. But again, the president of the policy enforcement agent is specifically they'd like to distinguish between these cases. And so, I mean, I'm not against another round of the arms race here. But let's be clear about what this is. No, that's really quite semantically confused.
Right.
Yeah. So in any case, the second point I got to make is I'd really like to see a pretty clear division between this case, which is effectively deprive ++, and this case, which is applications should be doing DNS from XHR.
You want to see a separation in the protocol, or you want to see two documents that are running in parallel?
I'd like to see separate use case descriptions of what these are for, because it's not clear to me they have the same protocol requirements, and it's pretty clear that they have different security settings.
Yes, sure.
I mean, and architecturally, it's pretty clear that like they actually involve. And by the way, just like this whole thing intermixing, right? Like already involves hoisting the resolver all the way up into like the browser, which by the way is like extremely problematic for other reasons. So
Not all browsers, but yeah. Okay.
Well, I mean, if you're going to intermix HTTP, I mean, the only things is like do like a lot of the kind of HTTP intermixing are basically browsers, right?
So far.
So yeah, so far, sure. Again, we're back to the hypothetical.
With 5 minutes left on this topic, we still would like to have some time to talk about next steps. So can we move quickly, please?
Sure. Brian Gondwater, I actually have 3 points. I'm going to go through them very quickly.
good.
The first was about only web browsers are going to want to use this. A fine example of something that can't do DNS at the moment is Thunderbird. It can't do SRV lookups because it doesn't have a cross-platform way to do SRV lookups. And that's that kind of application where they want to do a lookup that's not just an A record and they want to be cross-platform. This seems fantastic for. The second thing was HTTP 2 versus HTTP 1.1. As far as I could see from your examples, it's purely political. There's no technical reason that it wouldn't work over
In the
HTTP
draft,
1.1.
we actually described the technical reasons.
Okay. And the third point there was the formats and requiring only the UDP wire format. It's going to be a lot more complex for developers to deal with that rather than a simple JSON format where you say, here's the key, here's the value. I want to look this up. Not everybody wants to do DNSSEC lookups. Some people just want to look up a record and get a response back. They're in an environment they trust. Having a format that makes that easy will make it a lot easier for developers to move to this rather than just using DNS lookups. That's it. Thanks.
Ben Schwartz, I just want to point out that there are at least 2 non-interoperating attempts to implement something like this on the internet today. The 2 I could think of off the top of my head are OpenResolve and DNS.google.com. So that seems like an argument for standardization.
John Black, just a question. Is it considered one of your use cases that a JavaScript application could implement this with the browser being completely ignorant of it? So that, it could just make the, if it wanted SRV lookups or DNS sec validation or whatever, though I'm sure that'd be annoying to do in JavaScript.
Yep.
But so the idea is this can be an entirely the browser can be completely ignorant of this and it'll also work, right? Okay.
We're discussing this. We closed the mics a little while ago. Sorry. We closed the microphones were closed for this. We want to have the discussion at the moment about next steps for this work. Go ahead. You have some idea there? What we should ask you? Like you want to talk about deprive?
Okay, so we're struggling here between how much this relates to deprive and how much this relates to a new working group that was spun up about it. How much this relates to doing nothing at all. Hear comments on sort of the range of how we split this work up, what parts of it does, how it relates to existing things we have at IETF. Particularly from an AD.
Art ADs will be talking to int ADs about deprive later in the week.
Okay.
So we can obviously discuss. At the moment, I don't have answers for you.
What? Oh.
Well, we'll be talking to security ADs as well. There is no.
Yeah. So are next steps then the outcome of that conversation, or what would you like from procedurally from here?
Yeah, I'm hesitating to offer, to ask about mini charter at the moment, but.
Okay, so maybe we'll just jump to a different sort of one.
Yeah, I think it's quite clear that there is some interest in the community to do this work. We just need to find place for it and scope.
So can we get people to put their hands up that are willing to review documents and do work on this space? Wow, tons. Okay.
So Alexi, do you need anything else from here? Or? No. Okay. Thank you. Let me switch to the other next deck.
Oh, we need to get well, and we need to do the we're doing the box summary stuff?
Yeah, I'm doing that next. Okay. Where'd it go? There it is. So resume. So we did that. Very quick overview. I didn't get any replies from the BOF chairs. So these are the 4 BOFs that are appearing this week. Mark, you leaving the room, or you with the mic? Okay, he's leaving the room. Nice to see you again. If there's anybody who wants to chat about, give a quick summary of these. We don't need them necessarily. We can keep moving right along. Going once, going twice. And the only other working group that has formed since IETF 98 is DCRUP, which is, since I co-chair that, I can give the overview of it. Mostly just upgrading key size recommendations and possibly developing some ways to move larger keys through DKIM and through the DNS, since those are limited in the current specification. It's meeting this week, may well only meet once or twice during its lifetime. I think it meets Thursday. So Dave, Barry's running to the mic.
Just this is Barry Lee, but just to repeat what I said to the mailing lists, we've shifted the meeting time. DCRUP shares a session with DMARC, and was supposed to start at 11:30. No, at 11 o'clock, and we've moved it back 20 minutes to start at 10:40, so that you don't have to sit around in the room for a half an hour doing nothing, waiting for it.
Thank you. Dave.
All right, so I'm going to be talking about URIs with multiple transport stacks. Next slide. Okay, so recently, by recently I mean since last IETF, there have been at least 3 relevant requests for URI schemes that all have a common property. Okay, they were all asking for, I have this protocol and I want to have, foo.tcp and foo.udp and foo. Fill in the blank. Okay, that's the category of stuff. Those 3 requests that I'm aware of, the first one was from the core working group, which requested CoAP over various transports, right? Originally, CoAP was just over UDP, and now they're adding transports for TCP and WebSockets and so on. Okay, so that was the first request, and so they asked for CoAP plus TCP. They asked for those 4 schemes in addition to the other 2 that are widely deployed now. Second category was from, or actually the second and third were from other SDOs. The second one said, yeah, we just want to use what Core did, right? We have a dependency on those because we're doing some products. And so OCF said, hey, can you please just register those? We support that. And if you don't, then we'll just provisionally register them ourselves. Okay. And since the IETF basically said at the time, well, we're still trying to figure that out. We don't know whether they have consensus and so on. So right now, those are actually provisionally registered to OCF. And OCF was like, well, you're welcome to have them back if you want them, right? Pending this. But in the meantime, OCF is going to use them anyway. So that's kind of one of the things that happened. And then the third one was a different SDO, which is the OPC Foundation, right? So both OCF and OPC foundations are 2 different IoT SDOs, right? One is stronger in the consumer space, one is stronger than the industrial space. Okay. They also asked for a permanent registration of OPC over TCP and AMQP and WebSockets. Okay. It just so happens that both of them were ones that were using stuff, and I poked them to say, hey, you guys should register your stuff. And so technically, you can blame me for this becoming public because I noticed this and poked them. Okay, and so as a result of that, on the URI review list and various other lists, there was lots of discussion about whether this was a good idea or not. Okay, and so I wrote a draft to collect a bunch of the arguments and trade-offs and issues. Right now, this is not a document that tries to make any recommendations. It's a document that surveys, here's the possible things you can do, and here's the limitations and advantages and disadvantages of the various approaches for people defining URI schemes. Okay, so as the editor of the document that's 7595, I think I have that on the next slide. You don't have to, yeah, so 7595 is a document that says, here's the requirements for what it takes to register URI schemes. So I'm the editor of that one, so that's why I'm doing this one. Okay, go ahead and next slide. Okay, so to summarize what problem this is trying to address, right? There's a section of the document that tries to summarize the problem, right? And it's gone through 2 revs so far, as I've captured more of the discussion from and points that people have made on the list or various lists. And I'll keep updating it as long as there's new things to add here. So today, there's lots of cases where 2 URIs for the same resource occur, and they differ in, say, URI scheme, like SIP and SIP-S, for example, or HTTP and HTTPS, or authority, like 2 different domain names, or perhaps more commonly 2 different IP literals, okay, in different URIs. Or path, right? Maybe, you know, ... resolution and so on. There's plenty of examples of all 3 of those where you have that. And 3986, which is the URI RFC, explicitly allows that and says, yes, it is perfectly fine to have multiple URIs for the same resource, but you should minimize that, okay? And so why should you minimize that? And so 3986, and there's some W3C documents that's referenced the architecture of the www, talks about things like the more aliases that you have, the harder it is to do things like, how do I know whether those are pointing to the same resource? How do I have values of things to say this resource is more valuable than that one because it has multiple pages that point to it or multiple other resources that point to it, right? And so the more aliases there are, the harder it is to do certain higher level things, okay? So I tried to capture that. And so 3986 actually has this ladder level of different types of comparison, right? I can just compare strings, or I can have protocol scheme specific knowledge to do better job of finding duplicates and so on. But in general, this is allowed, but not sort of appreciated, right? It's sort of minimized where you can, right? 7595 has, here's the requirements for a permanent scheme, right? So URI schemes have permanent and provisional. And 7595 is what changed the process for provisional to say it's first come, first serve, right? So if you do provisional, you can do whatever you want. It's just first come, first serve. IETF standards have to have permanent. Okay, so if it's coming out of the IETF, you don't have that choice. You have to follow all the requirements in 7595. Okay. Now the requirements for permanent don't actually talk about this particular topic. There's no explicit requirement. Now, it does normatively reference other things, but there's nothing you can really point to that says, here's a specific requirement, and so that's why it's fuzzy and why there's this debate. Is it a good idea? Is it not a good idea? Well, there's no explicit requirement. It's just kind of frowned upon, right? Okay, so that's the problem. Next slide. Okay, so here's an example use case, and there's plenty of use cases, but I picked the use case out of OCF. Because I think it's a number of people were arguing, well, you should do such and such instead, and this is kind of illustrative of something that's partly there to illustrate why people want to do this. Okay, so in OCF they define a higher level API, right? If you're familiar with like ID and locator, you can think of this as the ID, right? No matter which protocol that you're using to get to it, no matter which IP address it's at, no matter what port number it's on, they have a higher layer API that's unique for that resource. Okay, it's OCF : / hash of a public key / rest of the URL. Okay, so in their case, using a hash of the public key allows them to cryptographically bind the URI to the actual cert that's being used to authenticate it, right? And so it doesn't have a dependency on DNS or any PKI. You can use that, but you don't have to. Okay? So that's why they did that. But it also follows the constraints of, you know, you want a single unique URI that the application uses for a resource. Okay, but you got to have a way of resolving that ID to a set of locators, right? I got to know what the IP address and the port number or which protocols the server is exposing if there's multiple of them. Got to have a way to know that, okay? And so they have this way of saying, when I learn the URI, I can learn the set of locators, okay? And in their example, they said, well, those locators, we could use URIs or we could use something else for the locator level, okay? Now, some of those might be WebSockets which use URIs, so they chose to say, we're just going to use URIs for everything out of the ones that they supported. Okay? And since Core was defining ones for CoAP, and we got ones for HTTP, and WebSockets has one, they said that should be sufficient to just use URIs, okay, as opposed to some other way to encapsulate, you know, port numbers and so on that's not in the URI syntax. And so when we go through the list of approaches, you'll see that. This is just an example use case. Okay? And so there's various types of resolution in the OCF. It's the way that you get the URI. It comes back with this additional information. Sort of like the additional section of DNS, right? You might want to have this stuff too, and that's where you get the locators from. Okay. Now, in the OCF case, this doesn't happen, but unless you have CoAP over things. But you can actually have, in the more general case, we have an application layer protocol that might be capable of using 2 protocols to the next lower layer, and each of them might be capable of using 2 things below. So you can, in theory, have this stack of stuff, which is hopefully rare, right? Most things only have 1 ID locator level split, but it's impossible to chain those and say, well, I have an ID, and then I have a locator that's actually an ID that has a locator below it, right? And so in more complex cases, you say, well, I actually have this, you know, how many levels of this tree of locators? It gets to be fairly complex, right? All right. Now, OCF didn't have that problem if CoAP over TCP and CoAP over UDP were compressed into 1 level, right? Which is what Core was doing. know if you follow that. Next slide.
Oops, sorry. There you go.
Okay, so some of the discussion I want to tease apart two concepts that came up in the various mailing list discussions. There's the concept of discovery, which is, as a client, I want to just discover what are the possible protocols and identifiers of those protocols. By identifiers, I mean things like port number or whatever the appropriate thing is for that protocol. How do I discover what the possibilities are, right? That I call discovery. Versus selection. I have this set, and how do I choose which one I'm going to use? Okay, is it happy eyeballs like thing, where I'm trying things in parallel, or whatever? Those are two sort of orthogonal topics. I got to discover a set, and then I got to have some mechanism to choose from within the set. Okay, and it's up to whoever's defining the URI scheme to specify, here's the resolution mechanism for discovery, and here's what we expect for selection. Constraints or the one to use or whatever. Okay, so most of this document is actually about the discovery aspect. But since there was plenty of discussion about the selection aspect, there's a little section on there too that summarizes the arguments. Okay, next slide. Okay, so the last two slides, at least I think they're the last two, actually summarize the 4 different discovery approaches that are either used or at least discussed as possible in theory. Okay, and it enumerates a number of different trade-offs of each one and sort of problems of each one. And I don't know if there's any other ones. And there's probably other advantages and disadvantages of each one, and I'm happy to collect those and update the document as people know more or point out more. So the first category of things is where just the URI scheme definition specifies everything. Okay, so for example, TFTP is a scheme that says it's only UDP and it's only a particular port number. They don't have any higher layer 1, right? And so that was one of the discussions around the core working group, which happened, I guess, a couple days ago, was, should there be a higher level 1 or not, is kind of the open discussion that I think will be going on in the core working group. Okay. And again, if you have multiple layers, there can be complexity there. It's still possibly solvable if you have multiple layers of resolution or a way to have a stack of URIs or something. Okay. And if you wanted to have a different transport stack in the URI, the only natural place to put the transport identifier right now is into the URI scheme. You can kind of hack around other things, but the sort of COAP plus TCP is the only natural way, because the scheme is what sort of identifies the protocol stack as the closest thing today, like HTTPS versus HTTP. Okay, so that's why people do that. Okay, so that kind of collects a number of the arguments that showed up around that area. And then the fourth one is the notion, well, why do you need to use a URI format in the first place? Why don't you use something else that's not a URI format? Yeah, you got the information. Yeah. Go ahead, Jonathan.
John Lennox. Yeah, I mean, there's the pattern that you see in SIP, and maybe SIP is an anti-pattern, I don't know, but SIP and turn and things like that, where you put as a parameter, transport equals TCP, transport equals UDP.
Yeah, the draft actually does talk about that, and the argument for it, so obviously there's arguments both ways, right? So the argument for the anti-pattern is once you put it into the path of the query, that means typically that gets sent to the server. Whereas the transport selection is typically a choice made by the client before contacting the server. And so it consumes extra bandwidth over the wire. Okay, so that's the counter argument for that one. But yes, that point is actually talked about in the document as well. If you got a question about point 4, let me finish that one. If you got a question about point 3, carry on.
No.
Okay, all right. So point 4 is that, well,
let me just say why we don't want to pollute the parser query.
Your name, please.
Thank you. So we need them for the actual protocol. So if you have a protocol that runs over CoAP and suddenly sees a question mark transport equals something, that's very confusing. So the resolution process that actually gives you absolute URIs still has to continue to work to give you the URIs that you actually want.
Just repeating, the point of the document is to not make a recommendation, but to collect a lot of the different ways that people have proposed doing it or are doing it, and to explain what the trade-offs are of each one. Okay, it's purely informational right now. Okay, so the fourth category is, well, for the locator level, you don't have to use a URI, using some other format and not trying to wedge it into the URI semantics, right? You might be using a URI for the ID layer, some common thing across transports, but then you're using some other format to say, where's my set of IP addresses and port numbers and protocol identifiers and so on, something that's not a URI, okay? The disadvantage, so it has the obvious advantages, which is you're not polluting the URI and you don't have multiple URIs that actually point to different versions of the same resource, right? And the disadvantage is just that across those, you don't necessarily have, without making up a new one, a common syntax for expressing those. Okay, and so you have to invent one of those, and if you do that, you can make it work. Okay, and so that's the other approach that Core could have taken, is invent a new syntax that's not URIs that embeds the same information. Okay, and so I said, well, why reinvent the wheel when we have, HTTP and we have WebSocket URIs? Let's just use URIs for everything. And that's the same conclusion that OCF came to as well, and presumably what OPC came to as well, which is this didn't have advantages they saw that were significant compared to number 3. Okay, so that's the trade-offs there. I think that's my last slide. I don't think I have anything else, right?
Still have something about point 4.
Open up to other things I can collect and put in the document.
Phil Baker.
I do have a next step slide.
Yeah, I've had to look for it every time, and I couldn't. We do actually have a document that describes in really good detail how to use SRV and TXT records for discovery. And I like the idea of taking all the cruft that exists and explaining it, but I would like the outcome of this to be, this is how you do it. Because at the moment, every time we have a working group, there is a discussion on how are we going to do discovery. And that is wrong. If we're a standards organization, we should actually decide on one way to do discovery. And instead of having that discussion in different places and coming to different answers, I'd like to come to one agreement on how to do it. I would want to have one registry of identifiers so that when I define a web service, I get my protocol name, and that gives me the port number equivalent, because port numbers are going away. It's giving me my SRV prefix. It gives me my well-known prefix. It gives me my URI. There is no situation in which if you've got foo bound to being an SRV prefix, that I want a well-known service for something completely different that's got the same name, nor do I want a URI that has the same.
Okay.
So I'd like us to get to some consistency and have one defined way of doing this IETF. And if people want to do it otherwise, then they should have a reason why they're doing it different, rather than the current, which is we discussed for 2 meetings how to do something that we've already solved 3 times before.
I see you generated a long mic line. And so the challenge is defining one thing that fits all possible purposes that people use URIs for, and that's why people end up with lots of debates. So go ahead, Keith.
Keith Moore. I'm actually not responding to Phil. I just wanted to take my time to try to formulate a response. I feel like I've gone back to 1993 because this is the URN program problem over again. And that, I think the end result of that, I'm very sad to say, as someone who put years of my life into that problem, was to create a huge honking mess. And the most recent working group in that area completely did not understand what it was doing. Does not understand what it is doing. I want to believe it's over with, but it's not. And I don't want to discourage what you're doing. I think your approach makes sense. It's like, let's just try to sort of state what this problem space looks like. But there's something really, really dangerous here. I feel like, or really elusive about this problem space. One of the problems that I've seen is that everyone looks at this extra layer in direction and tries to project their own idea or their own problem they're trying to solve on it, and then insist that that thing has to be what they want it to be. And when you have, thousands of different people looking at this kind of thing, each projecting their own ideas of what they want it to be on it, it's very hard to create anything coherent out of that. So I don't, again, this is nothing that you put up here. It actually all makes sense to me, but it made sense in 1993. I guess another thing that I'll say is when you define something like it, you define an identifier scheme. Okay, it could be URI or something else anyway. And it means something when you define it. And then later on in time, you try to change what it means. You try to insert a layer of indirection. We could be talking about IPv4 addresses. And, originally IPv4 address was, here's your, it's class A or B or C, and you've got the remaining bits, and here's kind of the location it is in the network, and here's the bits on that LAN. And then it's like, oh, well, we have to change how we do the classes, and now we have NATs in the way, and so this doesn't mean anything. And every time you add these layers of indirection, you break things. And then, so you have this tension between people saying, no more layers of indirection, no more breaking things, and people saying, but we don't want to change all these existing, things that expect this behavior, so we're going to change it out from underneath them and hope it doesn't matter. So anyway, I guess I really would like to anchor at least, the idea of URNs was we're going to anchor something and say, this kind of scheme is distinguished from all these other kinds of schemes so that you can at least tell the difference. And I still think that's useful. But there's no way to I don't know how you keep people from wanting to insert layers of indirections in the other things.
Right.
I think that's it. Thank you.
John Clenson in Jabber. Dave, seems to me that halfway to your 4th approach is to focus on identifying the resource and go with URNs, allowing the protocol to be sorted out as part of the resolution mechanism. But that is still a URI, not a different mechanism.
Mark Nottingham. I think that it is entirely appropriate for us to be giving this kind of advice and to be thinking and talking about it. I think there are cases that are different for, or different requirements for protocols that require, us to treat people like adults. that we can't just say there's one way to do it and you have to do it that way or it's the highway. Blue sheets, anyone?
Yes.
And so writing this kind of advice and this thinking and documenting these pitfalls or these trade-offs is important for us to do. So I would encourage you to continue, and I would encourage us to, to look into this area.
Thank you.
For me, we talked about this briefly before. I see this as part of a larger problem, which is how do we identify protocols? Because we have many of the same uncertainty and questions around things like ALPN tokens, which were an artifact in TLS that suddenly are being used for lots of other things as well. And we don't have good answers about how to use those appropriately or what the pitfalls might be. And then there's magic and port numbers and all that sort of stuff. So I'd actually encourage us to do more of this rather than less.
And the audience of this is sort of twofold. There's the IETF audience, which for standards anyway, has to do the permanent ones in which you can set requirements, right? We can say you have to do it the following way if we have things we can say. For other organizations that don't have to use permanent, then they don't have anything to look at right now, or at least nothing that's centralized in one place. It's scattered around. How do I know to even look in the AWWW document and so on? So can you go to yeah, that one. That's the one that I wanted the chairs to ask the question on.
So it's it's totally unprepared for your question.
What should I do with this document? Hey,
yeah.
dispatch. Hey, Arteria.
I guess, do you want to do a hum on? Yeah, we fell into the art area.
Area directors.
Nothing's really being dispatched yet, so this is a we have some sort of we should do a hum on. Well, is it? Thank you.
Area directors go to Mike now. Yes.
I was totally unprepared for that.
Can this be done within the dispatch charter as it's written now?
We could dispatch it, but
Okay, no, there was exception for IANA-related things, but I'm not sure it quite qualifies. That's why. Okay.
No, this
No,
one
just
is-
checking, just
yeah,
checking,
yeah.
you know, that.
No,
Yeah,
that- So the question is, do you want to AD sponsor it?
Let me throw something.
Okay.
This is Barry. It seems to me that what we do with it hinges partly on an answer to Phil's question, which is, do we just want an informational document that gives what options there are and what the pitfalls are, or do we really want to come up with an answer for a BCP or something of how you should be doing it?
Yeah.
And I lean toward that, which means that just AD sponsored isn't going to do it.
So my personal opinion is there can be two different efforts, and that you shouldn't combine them. So for example, the second effort may be one that entails updating at 7595, which is the requirements for permanent registration.
Yeah.
Right.
Right.
But I see
Adam-
that as a different document.
Right.
Thanks. Adam Roach. I agree with that approach. I think what we probably want to do here is get input from the art community on the art mailing list to see if this is kind of the right set of things to talk about. Again, not making recommendations as much as just, here are the emergent properties. And then we can circle back around and determine whether one of us will sponsor its publication. I think that's the best way forward here.
Phil Humbaker. From the point of view of next steps, I mean, mapping out the spot swamp is a very good start to building a path through it. And while I want to build a path through the swamp, we may need to chart it first.
Yeah, Barry, again, I'll agree with that as long as the mapping it doesn't make us forget about finding the gold.
Yeah. And I know if it entails an update to 7595, as the editor of that document, I'm probably on the hook to participate in that too. So.
Okay.
Thank you.
Thanks, Dave.
And finally, video delivery and hybrid networks. One moment while I get your slides.
Hi, good morning, everybody. So, would like to present something about video delivery in hybrid networks. The presentation will be just general because we are still trying to figure out where to go with this and to see if there's interest in this work at the IETF at all. So next slide.
Yeah.
Oh, okay, that's better. So what do we mean by multi-platform distribution for video? There's some use cases, mostly that the video distribution is done from one source to different networks, which may be like to cable, satellite, or to IPTV, and each one of them requires a different way of packetization and of getting the media. Most of them are pushed. We're talking mostly about the push technology in these cases. And the other one is, of course, the over-the-top, which needs to provide the same contents. Sometimes it's a live video to different platforms like IPTV, which basically would run RTP or into places where it will be received via HTTP, like Dash or something like that, via CDNs. Next slide. So there's a very big diversity on the IP distribution. You can see the encoding can be different, like MPEG-2, H.64, H.265, HEVC, and VP809. The packetization may be different, which is Dash or HLS, depending on the protection mechanism is different. The streaming is different, can be HTTP or RTP. Distribution, different type of distribution, multicast for the UDP, unicast for HTTP, and ABR is something that's basically it's multicasting in the middle for distributing live video. And the devices can be set-top boxes, iOS, Android, PCs on the receiving side. The overall, when you have to start and prepare the content for this all these platforms, you may need to prepare different packetization, different delivery for the information coming from the same source, which makes it complicated on the head end or the equipment at the receiving side. Next slide. So the transport protocol, we see there's the file mode, which is mostly on the HTTP, where you have pull mode or push mode. The codec, the packetization is ISO MBFF or MPEG-2 transport stream. It's on the unicast, it runs over HTTP. Some multicast using norm flute to do a multicast over UDP. And on the packet mode, which is basically RTP, it's the codec or transport stream over UDP, and all running over IP. So these are most of all the transport protocol. Next slide. So the impact of the diversity is that file mode is usually done in pull mode. For push mode, it usually uses a reliable transport protocol like norm or flute for multicasting part of the route. It usually applies method like retransmission to recover lost data, but then there's low latency. The low latency is sacrificed. Another way to transport in push mode is to convert file mode to packet mode, which means to take to push the information by multicasting in the middle. It's suitable for applications that can tolerate certain packet loss, so that latency requirement can be satisfied. A gateway is needed to take out the container and extract the codec to fit in the content aware protocol like RTP. And the codec should be authorized to do this. That's a problem it needs to do with the media protection issues. Another protocol is that it's difficult to convert back to file mode on the receiver side if you go from if you start file mode, packet mode in the middle, and then you go back to file mode on the receiving side. Next slide. So when looking at that, if you say we described a lot of issues, we didn't describe yet what we really think we want to do here. MPEG has done some effort to provide convergence for this diversified situation in common formats, that's for packetization like MMT or CMF, but this is more file mode. We can simply transfer MMT over RTP, but this is not something that is good enough. We're not sure that it's good enough.
So the question we are asking ourselves is, do we want to work on convergence of file and packet modes in the IETF to offer a solution that will work? One of the directions we looked in the past, and we tried to look at it, is at least for distributing. The major problem we see a lot of problem today when we have live events, where a lot of information is being transferred to, the same information is being transferred to multiple receivers. And when you're using HTTP, it's just multiple connection, or either heavy load on CDNs or multiple connection to the source. And what we were trying to look here in the past was about, for example, is to define how to do to convert it from unicast to multicast near the sender, and back from multicast to unicast in the set-top box or whatever, or even go directly to the end device if the end device support IPTV, for example, that can run RTP. So So what we were asking ourselves here is that, do we want to work on convergence of file and packet mode? Is some content agnostic application of a transport method should be developed in the IETF? Mostly that's what we're talking about, multicasting or RTTP, using RTTP. And we think that if there's interest, we can start discussing the issue offline during this week by having some offline meeting and with people who are interested in this work at the IETF.
I mean, of the people who build these types of systems on either the one mode or the other mode today, are there people who would be interested in changing their systems to support something new from the IETF and working on it? I guess we can have a sort of show of hands of that.
That's not necessarily.
Okay, well, what should we have asked?
So it's not necessarily, because what we're not only talking about changing the way it is going end to end, but even in the middle to try to find a solution that will help us with the delivery of the video from the sender side to the receiver side in a more optimized way than it's being done today.
So I suspect we're saying this is sort of an advertisement for work, and we'll carry on discussion on the art list. But are there people who are going to participate in this conversation? Okay. We got one hand. There's another, two. And yes. Take a third. Come on, Magnus, say yes.
So, Magnus Westland Eriksson. I mean, I talked to Ronnie before. I think this is way, way, way too fluffy because it's.
Okay.
It really is a question of which of several different problems that might belong to IETF we can actually work on in this space. There's like the question, how do you invoke multicast from like browser environments, etc., HTTP, etc., all services needs, things like that. There's questions about does our multicast reliable transport protocols have all the features needed for the use cases, etc. And then there's topics like, which definitely not belong in ours, like does the metadata in the kind of data stream which belongs to NPEG, which is clearly not ours. So I think we need to be very clear on what, if anything, belongs to us here, because it's easy to step over the borders here, I think, into where the primary people are actually in order for us.
Yeah, I agree. I think one of the issues we encountered when we're trying to look at this problem is that we need to start with understanding first the general architecture and describe the architecture and how it's going through the whole process, going from the source to the receivers. And we're not sure even if that's the things that's being discussed in the IETF, because it's more like a system solution, not specific protocol. So we were wondering, so we can start with providing some more information about the structure and where we think we can do, but we were trying to figure out if there's even an interest to work on this topic at all, because if there's no interest in doing anything in this area, then why should we start to write documents and try to describe something that's not of an interest?
Keith Moore. I started out thinking this is mostly an MPEG problem, and then I think there might be a role for some sort of collaboration between IETF and MPEG. But at least in my experience, it seems to me from what I've seen that MPEG is used itself in so many different ways that, at best you could hope for is a sort of profile of MPEG that could be used to feed into, a network architecture maybe defined here. But if you don't have the original content in a format that is amenable to all this different kinds of slicing and dicing, there's not much we can do about it.
I think, go ahead.
Yeah, I agree with that. I think that we are not trying to change what MPEG was proposing. We are thinking that some of the protocol and some of the packetization that MPEG defines makes sense to use, but we are trying to see how to transfer them in a better way in a network that will allow us to get better performance. And mostly we see this problem with live video, where you have to send a lot of, you have a multiple receiver receiving the same information. And that MPEG doesn't address this issue at all. This is things like MPEG. Some discussion was in cable labs, but there's not something that we can say this is the way to do it or thing. And maybe this is the thing we need to address here. But as I said, we need still to start and provide the whole view of what is happening and where the problem we see.
I think we should just encourage conversation about this to continue on the art list and to get answers to your questions about interest and where you would like to go from here. Okay?
Okay. Thank you.
Thanks.
Cool. You sure? Okay.
No? Okay. Thank you very much. Do you want to do this new item?
There's no, yeah, so moving on to open mic. I think there's
We
Volker.
had one quick request for open mic time, and then we'll wrap up.
Hello, my name is Volker Birk.
You need to be up here in the box for people remotely. The box of shame up here. Yep.
Okay, whatever. Okay, hello. My name is Volker Birk. I'm from Pretty Easy Privacy, and what we're actually doing is we already implemented plenty of free software, which is doing opportunistic encryption of what we call text messages. We started with doing opportunistic encryption of email, and now we're going through Jabber to other text message systems. And you can download lots of software there. And what we're doing is we're trying now to influence people that we can make all what we are doing as an open standard. So we are text-free NGO and have that idea. And partly we want, of course, try to influence you guys from the IETF that maybe you want to have a look on what we are doing. Because that's a dispatch session. I mentioned things which could be in the scope of the IETF. I don't know. I'm new here. Okay, for example, we have a protocol stack which we call sync, which is synchronizing keys and trust between devices. So if you have a multi-device setup, then we are doing a protocol stack for the synchronization of keys and trust. But we also will synchronize addresses and your schedule. And internally in our database for making that happening, we have local databases. It's a peer-to-peer, 100% peer-to-peer concept. So we have always a local database. And there we, unfortunately, are using URI schemes, which are not standardized yet for things we didn't find a standard. Because we always depend on common standards. I have to mention that once. We depend on, for example, OpenPGP and S/MIME. And when there is no standard, we invent something our own. That is basically what we are doing. And we have identity management. We have crypto rating, which goes into user interface things. And we have message formats, which we add where we want to add features which are not available in OpenPGP and S/MIME. So they are commonly MIME-based, and there are some non-MIME-based for message transports where that does not match. And we have key mapping, what we call key mapping is you can use the same key for SMIME and for OpenPGP opportunistically. And even if there is a message transport like SMS, which we support, which is too small for such messages, then we have auto mapping on symmetric keys, which are temporary. Okay, so that's different topics, and I would like to be introduced where I can address them. Thank you.
I think the first place to start would be submitting drafts if you have any. And once you've done that, post to the art@ietf.org list and introduce the work so that this community can have a closer look at it.
Okay, very good. Thank you.
Yeah.
Is there any questions? Or?
We have like 20 seconds, Matt.
Matthew Miller, just one point on things related to XBP. You might want to go to the XBP Standards Foundation, the standards at xbp.org to bring that up if it's specific to that protocol.
Okay, thank you.
Jabber.
All right, blue sheets are at the front if you have not signed them. Thank you for coming to Dispatch. We'll see you in November in Singapore.
I need my DLA back.
Oh, yes, of course.
Otherwise,